On my list of vintage computers to restore was this, a Power Macintosh 7200. If you're familiar with Apple's history, you may recognize it as one of the company's so-called Malaise-era computers, from a time in the mid-90s when mismanagement and stiff competition left Apple releasing subpar products. And to me, at least, the 7200 was a perfect example of how Apple couldn't get out of its own way. Around back is the typical complement of ports for the era: audio, ADB, video, serial ports, Ethernet, and SCSI. Built-in networking was a nice feature to have for 1995 when the 7200 debuted, but a sign of the times was the inclusion of an AAUI port alongside 10BASE-T. Networking standards were still sorting themselves out, so an AAUI transceiver gave you flexibility in terms of physical cable types. The 7200 was considered part of Apple's business or professional computer lineup, and it was one of the company's first models to include PCI slots. I got inside to see how much work I had ahead of me. Time has not been kind to these machines, with their plastic parts becoming very brittle with age. There's an internal metal structure that helps support the weight of a monitor placed on top, but the machine's cover is primarily plastic with only thin shielding, and I don't think this would hold up to a CRT these days. I also had to be delicate with the flap that covers the card slots and the latches that secure the drive bays. But with those latches released, I could hinge the bays to the right to get full access to the motherboard. To keep that assembly's now brittle plastic foot from crumbling, I supported it with a tape measure instead, which was handy and close enough in height. Thoughtfully, Apple's designers included a kickstand for the inside of the drive bay too, which keeps it from slamming closed accidentally as you worked inside. There were already a few pieces of broken plastic rattling around in the case, and I was sure I'd run across, or potentially make, more while restoring it. I had two primary concerns, both related to potential electrolyte leakage. First were the surface mount capacitors, of which the 7200 had quite a few. These can corrode traces and solder pads when they leak, and at about 30 years old, their time is running out. The other issue is the clock or PRAM battery, which can be catastrophic if it leaks. But thankfully, it looks like I remembered to take it out when I got this machine a few years ago, which is a habit I've gotten into with all of my vintage computers, and I recommend you do the same. This 7200 appears to have never been upgraded. I can tell because it only has one stick of RAM, likely 16 megabytes, and the original 1.2 gigabyte hard drive, a Quantum Fireball with SCSI interface. We'll see if it still works a bit later on, but for now, I wanted to remove the motherboard for closer inspection. This was relatively easy to do, likely more for manufacturing efficiency than as a benefit for owners, since replacing it should have been an unlikely occurrence. With the cables disconnected, I could remove a single screw with a series of plastic hooks, allowing the board to slide forward. Oh, that's right, I need to pop out the front power button first. It's clipped into the case and very simple. A plastic piece extends inside to press a small switch on the board. Of course, it's already starting to fall apart, with one of the hinge pieces breaking off with the slightest touch. I was able to tease it out without further damage, but dealing with this is something I added to my mental checklist of repairs to make. From there, the board easily lifted out from the chassis. I was never a big fan of this model as it suffered from a series of compromises and design flaws that turned into a bit of a fiasco for Apple. At the time, the company had made a series of bad decisions, some technical but most related to business strategy, and those bad decisions kept compounding. The transition to PowerPC processors in 1994 was not especially smooth, and licensing the Mac OS to other companies caused a wave of so-called Mac clones to eat at Apple's margins. The 7200 series got swept up into a storm of negative press surrounding several other models that had serious hardware or software flaws. And the popularity of Windows 95 didn't help matters either, causing some fed-up Mac users to abandon the platform entirely. As I brushed the dust off the board, I was relieved to find that there weren't any obvious signs of capacitor leakage. But then I was annoyed at how close Apple put some of these caps to the CPU heatsink, so that meant it needed to come off. PowerPC chips in this era were actually pretty efficient, so a small passive heatsink with simple retaining clips was all that was necessary, though the thermal paste application could have been better. There were 3 models of the 7200. At launch in August 1995, you could pick between 75 and 90 MHz versions. By February of the following year, a 120 MHz model was released, which is what I have. All 3 used the PowerPC 601 processor, which itself has an interesting history. Since its inception, the Mac had used Motorola's 68000 series of CPUs. But by the late 80s, improvements to that line weren't happening as fast as Apple needed in order to keep pace with Intel. In 1990, Apple started working on moving the Mac platform to Motorola's new 88000 series of chips, which leveraged a RISC, or Reduced Instruction Set Computing architecture, that promised far better performance. Problem is, Motorola wasn't as committed to processor design as Apple needed. There was a strong chance they would have been the only computer manufacturer using it, potentially leading to another scenario like Apple was trying to escape from with the 68K. In a perfect example of the old saying, "the enemy of my enemy is my friend," Apple partnered with IBM, who was also concerned about Intel's dominance in the CPU market. They needed to act quickly, and IBM had already started work on its own RISC processor it called Power. To ensure that it wouldn't turn into a one-sided relationship, Apple invited Motorola to join on as well, and the so-called AIM alliance was forged. AIM, get it? By 1993, after less than 2 years of development, the PowerPC 601 was in production. It was largely based on IBM's Power architecture, but also incorporated aspects of the Motorola 88000 series, plus some specific features Apple wanted. The neat bit of trivia is that IBM left in the complete instruction set from its Power design, not just the parts necessary for PowerPC. That's because it had hoped to use Power chips in some systems it had already started developing. This meant IBM could use PowerPC processors in their place and they'd work, but also that Power Macs with the 601 had parts of their processors going completely unused. The 601 lived a double life. And to extend this machine's life, I needed to replace the capacitors. It was just a matter of time before they'd become problematic anyway. Due to their proximity to a number of plastic parts like connectors and slots, I chose to clip them off the board. If done carefully, this leaves their leads intact and reduces the risk of damaging the solder pads underneath. In some spots, I used pieces of Kapton tape to protect those plastic parts from damage. Then, with a bit of flux, I could easily pick up those leads with a soldering iron. Another pass with some desoldering braid left the pads clean and ready for replacement parts. I usually opt for tantalum capacitors as I feel they're a better long-term option. They can't leak like electrolytics. Some folks are quick to point out that tantalums tend to fail suddenly, and this can be true, but given the relatively low amount of usage of vintage computer Cs, I'm not sure there's actually that much risk. Before I knew it, I was all done, though I'm a bit embarrassed to admit I lifted a solder pad in the process. Thankfully, it was on the ground side and easy enough to work around with a bodge wire. In a few spots, there was a tiny bit of leaked electrolyte pooled underneath the capacitor, so it looks like I got to this board just in time. I needed to apply some new thermal paste to the CPU next, and while this machine probably doesn't deserve Arctic MX4, it's what I had on hand. So I applied the perfect amount to the chip and carefully clipped the heatsink back into place. A 256 kilobyte level 2 cache card came with the machine, so I dropped it back in, along with a small upgrade, a 1 megabyte video RAM module, which should unlock higher resolutions and bit depths. The original stick of RAM went in as well, but I figured I could do better than 16 megabytes, so I dug through my bin of vintage RAM to find some more. The 7200, like a few other models from that same time, used 168-pin DIMMs. But instead of SDRAM, which came later, these are EDO or fast page modules. I picked out a couple of sticks that looked promising, but I couldn't get them to seat correctly in the slots. It's because the notches in the RAM didn't quite line up, and after a moment, I remembered why. 168-pin DIMMs originally required 5 volts, but as technology advanced, 3.3 volts became the norm, and in the process, the notches were moved so you couldn't accidentally install the wrong kind. The 7200 and its siblings required the former, which is far less common, but I found a couple of modules that looked promising and installed them. I wasn't sure what size they were, so I was eager to reassemble the computer in order to find out. As I was reinstalling the board, I spotted a stamp on the bottom of the case. It was made on June 4th, 1996, about midway through the 7200's time on the market. Those retention hooks seem to have been made of a different kind of plastic that's less brittle, so sliding the board into place and reconnecting the cables was uneventful. As a replacement for the original PRAM batteries in vintage Macs, I've been using these adapters, which take a normal CR2032 coin cell. While it's possible that these can leak over time too, it's less likely, and because they're physically smaller, there's less damage they can do if that were to happen. There was also something curious about the wiring harness for the power LED. It has 5 positions, with a pair of wires going to the LED and a wire jumper bridging 2 other pins. The silkscreen on the board says Box ID, but I couldn't find much info about it in the schematics. Those pins ultimately go into a controller chip Apple called Grand Central, which is kinda like the North Bridge in PCs from this era. So while the schematics didn't delve deeper into what this was for, at least it's obvious that the designers had some fun. The first page lists the 7200's codename, Catalyst, and the whole thing is awesome, with Sailor Moon and Hitchhiker's Guide references. Anyway, with things back together, I ran into a problem. The design of the back of the case has this lip that extends out at the bottom. I wanted to use an external blue SCSI to boot the Mac from, but that lip got in the way. It wouldn't plug in. My friend Kay Koba from Carol's Mac Mods had recently sent me a couple of neat adapters designed to solve this very problem. They came in kit form, and the one I wanted to assemble first is called the Quadras stepper. It's deceptively simple, an extender for the SCSI port to get past that lip, and its name is in reference to Apple's Mac Quadra line, which also inexplicably had a similar design quirk. The other gadget Kay sent along is even more convenient. Macs from this era had their own 15-pin video connector, so to use a normal VGA monitor, an adapter is necessary. These commonly had a bunch of dip switches on them in order to set different video modes, and it was always a frustrating experience to try the various combinations to find one that worked. Thus the Mac VGA Lite, which promises to take all the guesswork out of it. Assembling both kits was very easy with only a few parts. I love things like this, since they can make using a vintage computer much more convenient, and buying them helps out the folks who put a lot of time and effort in to support the community. Even if you don't have much experience soldering, either of these would make for a great project. Just make sure you use flux. Quadras stepper is plug and play, with no options other than pads for an optional LED if you want to add more blinky lights to your setup. Mac VGA Lite has a single switch, which you can flip depending on the system and monitor you're using with it. One position is for multi-scan displays, while the other gives you a fixed 640 by 480 resolution. That's it, no dip switch voodoo necessary. And sure enough, my external blue SCSI can plug in now, and I made sure the VGA adapter was set to multi-scan mode. As for monitor choice, I went with a very not period-accurate 15-inch LCD. I don't think the 7200's brittle case could support something much heavier without cracking. Well, that was definitely a good sign, and I held Shift-Command-Option-2 to tell the machine to boot from SCSI ID 2, which I had the blue SCSI configured to use. but it booted from its internal hard drive instead, and I was surprised. Not just because the blue SCSI wasn't being used, but also because the original drive actually still worked. And the video adapter worked perfectly. The blurry image on the monitor was due to interpolation, and a check of the control strip showed it was set to a resolution of 1152 by 870. A quick flip to the LCD's native resolution of 1024 by 768, and the picture quality was perfect. So what about that RAM upgrade? About this Macintosh showed 48 megabytes, meaning the 2 sticks I added were 16 megs each. That's a healthy amount for a machine from 1996 and is plenty for most anything you'd want to tinker with today. I launched the startup disk control panel and selected the blue SCSI from there, then rebooted, only to get an error message. Turns out the image on my blue SCSI was slightly too old to work with the 7200, which certainly explains why it didn't boot from it before. Fair enough, and that gave me an excuse to test out the CD-ROM drive. Mac OS 8 was a common version to run on these machines, but when I tried to boot from the disk, it got part way, then threw an error message too. I figured the drive was probably having issues, which is certainly plausible given its age, so I took the Mac apart again. For how relatively easy this case design is to work on, it's pretty cramped between the back of the drive and the power supply, so dealing with the cables wasn't exactly fun. The drive itself is mounted to a sled that slides into the chassis, and since that sled is made of plastic,
this latch is going to break, isn't it? Yeah.
Of course it broke right away. It took a bit of prying, but eventually I was able to free the drive so I could check it out. The sled needed to come off to expose the drive's case screws. Replacing the sled with one that wasn't broken was something I'd need to figure out later. These drives were manufactured for Apple by Panasonic, and this one is labeled as Model 600i. The I obviously meaning internal, and 600 referring to its transfer rate, 600 kilobytes per second, making this a quad-speed drive. I've generally had good luck with these, but nothing can escape the effects of time, so it's just as well that this one might need some repair. There weren't any surface mount capacitors on the underside of the drive's PCB, which certainly would have been convenient, so I needed to disassemble it further. With the tray extended and the front panel carefully unclipped, I struggled to remove the top cover. I figured maybe there was a hidden screw under this label, but nope. Turns out something far more clever was going on. I found a pair of black plastic latches on the bottom, and pressing them released the cover from the entire bottom assembly of the drive. I took out 2 screws holding in the PCB and desoldered a couple of leads for the drive tray motor. I was expecting to have to disconnect a ribbon cable from the PCB when I lifted it up, but again, nope. Another clever bit of engineering here. A clip holds the flat flex cable to the drive's chassis, so it perfectly aligns with the connector on the board. While there are several capacitors on this PCB, I was surprised to find they were all through-hole instead of surface mount. And I was even more surprised to see that they all tested okay. Which is good because I didn't have the right ones on hand anyway, and with nothing else to do inside, I put the board back in place. I did take the opportunity to clean the lens while I could, though it didn't look dirty to begin with. Overall, this drive was very reasonable to work on, which is helpful since I'll need to get back into it again later. Once my DigiKey order for the right capacitors arrives, I'll replace them out of precaution. But otherwise, good job, Panasonic. What to do about that drive sled, though? As usual, 3D printing to the rescue. I found a model that someone had made of this exact bracket and had one ready to install in no time. 3D printing has been a game changer for the vintage computing community as it makes it possible to do so many more repairs than before. If you need a part that isn't being made anymore, just make one yourself. By this point, the front power button had lost the other half of its plastic spring arm, so I needed to deal with that next. Perhaps unsurprisingly, someone modeled a replacement for this too, and I printed one out using filament that's about as close a match to the original case color as one can get. Problem is, this machine, like many others, has yellowed a bit, so the new button is different enough to be noticeable. I figured the easiest path forward was to simply transplant the original button front over to the new stem assembly. Normally I'd reach for super glue in a situation like this, but hot glue was the better option since it could be used to fill the gap and give me a little more working time to get the two parts lined up. It's not the prettiest, but only the front is visible when the top case is on, so it should work. And while the 3D printer was warmed up, I also fired out a couple of enclosures I designed for the goodies from Caro's Mac Mods. Both come as two halves, and I tried to make them as compact as possible so as to avoid that whole plastic lip on the back of the Mac problem. A quick fit test and, yep, works perfect. I'll have links to both of these in the video description. I copied a new image to my Blue SCSI, the original restore disk for the 7200 that I found on the Internet Archive. And then I ran into another embarrassing mistake. The case for the video adapter I designed totally blocks the ADB port. Oops, I'll need to fix that. But while I pondered my options, I booted up the Mac, and it started from the Blue SCSI just fine. Right before it got to the desktop, though, it popped up a dialog box about a floppy disk being unreadable. Supposedly it was an 800K disk, but there was nothing in the drive, and if I clicked eject, the message returned a few seconds later. Great, yet another problem to fix now. Oh, and here's one more. Apparently I screwed up the alignment of the power button face when I was gluing it together. I should have moved it a bit further to the right. Good thing I used hot glue, which wasn't too problematic to remove and reapply in the right place. I tried reseating the floppy drive cable to see if that would help, then slid the top case on, and the power button lined up perfectly. But when I started up the Mac, the drive was still doing it. Based on the sounds, it's like it was trying to read a disk that wasn't there. I've never seen this before, but wasn't really in the mood to work on it further, so I simply disconnected the cable.
Fine, be that way.
That got the computer to finish booting, and I could wipe the hard drive. I remembered that I hadn't tested the CD-ROM drive since putting it back together, so I tried to boot from that same Mac OS 8 CD, and got the same error as before. Then I got the crazy idea that I could try, another CD, and that one worked fine. It's funny how it's so easy to get fixated on a problem and go down a rabbit hole when the root cause is right in front of you. That OS 8 disk must be scratched in just the wrong place. Something I also found funny is that my generic System 753 CD is exactly the same as that restore disk image I had downloaded. Since that's what the 7200 shipped with, I figured I might as well go with it, and the OS installation went off without a hitch. The original mechanical hard drive is probably on borrowed time, but I'll take it for now. To make sure I didn't have any lingering motherboard issues, I tried connecting another floppy drive, and the Mac worked just fine, so the problem is for sure with the original drive. I'll look into that some other time, along with replacing the capacitors in the power supply. I also redesigned the enclosure for the Mac VGA Lite adapter to make it even more compact than before, and I'm happy with the end result, especially since it doesn't block the ADB port anymore. Restoring this Power Mac 7200 got me thinking about the very nature of collecting vintage computers. While it was a model that sold decently, at least compared to the rest of Apple's Macs at the time, that was largely because it was the most affordable machine in the lineup of professional models. It lacked the audio-visual capabilities or upgradable CPUs of its higher-end siblings like the 7500. Other than RAM and storage, there wasn't much further you could take a 7200 down the road. During this time, upgradability was a big deal because of the pace of progress, so things like a non-upgradable CPU could give a buyer pause. Well, at least until an obscure upgrade card from Sonnet Technology came along in 1998, but that's a story for another time. As mediocre as the 7200 was back then, it doesn't really matter now. The value proposition totally flips when you don't need a computer to actually do work on. Vintage tech these days is largely about tinkering and having fun. So is a supposedly subpar model really a problem? And that drives an even more important question. Why are you collecting old computers to begin with? Is it because you want bragging rights or internet points? Because some YouTuber told you that a certain model was cool? Or is it because you want to relive experiences you had in the past, or ones you missed out on? We've all seen popular models of old computers sell for impossible prices, while others go largely unloved. But those supposedly bad models can still offer good experiences because it puts where we were then, and are now, into context. And that's a sentiment sorely lacking on the internet. I went into this restoration ambivalent at best, wanting to get it over with so I can move on to something more exciting. But you know what? The PowerMac 7200 is perfectly fine after all. I mean, it kinda has to be. If it was truly awful, Apple wouldn't have sold any to begin with. That lack of context painted it as something not worth getting excited over. Just another boring beige box. Is it amazing? No, of course not, but it's competent at what it does. If you want a vintage Power Mac to play around with, it could be a good choice. So, all things considered, I think I kinda like it now. If you liked this video, I'd appreciate a thumbs up and be sure to subscribe. Here's another episode you should check out, and as always, thanks for watching.